Hi everyone. Today we are going to discuss about stationary anode X-ray tube. I am Gauri PS, lecturer, Department of Radiology, Global College of Allied Health Sciences. First about stationary anode X-ray tube. It has the features of fixed tungsten target where the electrons will be striking and they produce an X-rays, but it simply limits the low exposure, low current applications such as in dental x-rays, as the heat will be present only in one spot, unless like an rotating anode, which is used in general radiography. It has a basic design with a solid anode plate that is cost effective for specific uses. It has a characteristics of fixed target, low heat capacity, simple design, and application. In fixed target, there is anode which has a tongue which is made of a tungsten and will be only in a single position. That is low heat capacity. That is heat will be concentrated within constantly heated and will be limiting the tube's power. That it does not consist of a motor or a bearing such as which are present in a rotating anode. And it is used in dental imaging techniques. Principle, it works by the principle of generating the X-rays from high speed electrons which will be striking the target that is made up of tungsten, and they produce both Bremsstrahlung X-rays and characteristic X-rays where the most of the energy will be released as heat, and this makes them for suitable low volume uses in dental X-rays. The next is about the components. It consists of cathode, anode, glass envelope, and high voltage source. Usually in cathode, tungsten filament is present for electron emission. In anode, a fixed stationary, that is a tungsten block, which also acts as a target. And in glass envelope, it is a vacuum sealed tube which consists of an electrodes. In high voltage source, it drives the electrons acceleration. That will be fast moving electrons movement will be accelerated. The next is about working. Uh, Usually the electrons are emitted by the process of thermionic emission. That is, the current heats the tungsten filament and it causes it to release the electrons. A high voltage will be applied between these cathode and anode, and they will be driving these electrons towards the target material. These fast moving electrons, when hit on stationary tungsten target, it produces these X-rays. That is, mostly the heat will be that is energy conversion process takes place. That is, the heat will be mostly 99% of the energy will be converted into heat and 1% into X-rays. That is by two process, that is X-ray production in two process, that is Bremsstrahlung X-rays and characteristic X-rays. In Bremsstrahlung X-rays, the electrons will be deflected and their energy will be slowed by the target atomic nuclei. In characteristic X-rays, the electrons will be knocking out the innermost shell of the electrons, and the outer shell electrons will be falling in and towards, and they will be releasing the specific type of energies. The X-ray output generated in these X-rays will be exiting out of the tube through a window where these X-rays, then with the help of these X-rays, several images can be formed in general radiography. Usually we use only rotating anode, and generally this method is currently not in use proper. The next is about limitations. There is heat dissipation, restricted power and exposure, reduced dose efficiency, low image quality potential. In heat dissipation, the stationary design will be limiting the heat management. It restricts the use of low intensity, low volume applications. In restricted power and exposure, due to the heat, it cannot withhold the high tube current or long exposure times. That is reduced dose efficient due to the continuous usage. The anode surface will be deformed and it will be shifting the tube angle. Thank you.